Welcome to The Explainer. Today, we're tossing casual home cooking right out the window. We are approaching dinner with deadpan scientific seriousness. We're going to break down the highly structured thermodynamic process of a dish that is just as efficient as it is comforting. We aren't just making dinner tonight, we're executing a precisely calibrated culinary protocol.
Okay, let's dive into this. The source material defines the Tex Mex Goulash protocol as a one-pot thermodynamic process. The goal here is simple but highly specific. We want uncooked elbow macaroni to absorb a boiling, heavily spiced tomato and beef broth. When executed correctly, this generates a rapid, high-yield, complex carbohydrate and complete protein matrix. Our ultimate objective today is to create this exact nutritional matrix and achieve total structural culinary success.
To pull this off, we're going to execute 5 strict mission phases. First, Protocol Alpha, the base. Second, Protocol Beta, the acidic matrix. Third, Protocol Gamma, gelatinization. Fourth, Protocol Delta, the lipid finish. And finally, Phase 5, the Red Team report.
All right, Phase 1, Protocol Alpha, the aromatic and protein base. To initialize this phase, you're going to want to bring a large, heavy-bottomed skillet or a Dutch oven right up to medium-high heat for even heat distribution. Once you've got optimal thermal energy, it's time to deploy the initial payloads. We're introducing 1 pound of 90% lean ground beef, a cup of diced yellow onion, and half a cup of diced green bell pepper. Now here's a fascinating detail from the source material. That 90% lean specification is a highly deliberate choice. Using 90% lean meat drastically reduces lipid pooling. Basically, it prevents a greasy final product and literally saves us the entire step of having to physically drain excess fat from the pan. It's all about maximum efficiency.
And this brilliantly illustrates the necessary chemical transformation of our base. We are looking to execute the famous Maillard-Browning reaction. This requires a precise 6 to 8 minute thermal process. You need to maintain the heat and keep those components moving until the meat is thoroughly cooked and the alliums, your onions and peppers, have completely softened up. This right here is where your foundational flavor matrix is built.
Moving right along to Phase 2, Protocol Beta, the acidic hydration matrix.
Now this phase requires absolute precision. Macaroni needs to absorb liquid to cook, right? But we face a tricky chemical challenge here. The acidic tomato environment actively slows down starch gelatinization. Balancing that acid with water is absolutely crucial. First, we deploy the liquid acid matrix, one 14.5-ounce can of undrained diced tomatoes with green chilies, an 8-ounce can of tomato sauce, and exactly 1.5 cups of water or beef broth. Simultaneously, we deploy the flavor payload. That's a 1-ounce packet of low-sodium taco seasoning, half a teaspoon of ground cumin, and a cup of frozen sweet corn. Once all these components are fully integrated into the beef base, you've got to bring the entire liquid matrix up to a rigorous rolling boil.
Which brings us to Phase 3, Protocol Gamma, 1-pot starch gelatinization.
Now, what's really interesting about this next step is that it completely flips traditional culinary wisdom right on its head. I cannot stress this enough. Do not cook the macaroni separately. No way. By cooking the pasta directly in the boiling sauce, you actually force the starches to release right into the matrix. This is a vital mechanical step because it naturally thickens the sauce, totally eliminating the need to create a separate flour roux. The pasta itself becomes the structural binding agent for the whole shebang.
So here's the exact methodology you need to follow. Step 1, stir in exactly 1.5 cups of uncooked elbow macaroni. Step 2, immediately drop that heat down to a low simmer and cover the skillet tightly to trap all the steam. Now Step 3 is where you really need to pay attention. You must simmer this for 15 to 20 minutes, but you are required to agitate the mixture by stirring it every 5 minutes. If you skip the stirring interval, the pasta resting on the bottom will scorch right against the conductive heat of the pan, and that seriously compromises the entire operation.
You'll know you've achieved biological readiness when the macaroni is fully tender and has absorbed roughly 90% of the ambient liquid. At this 90% absorption threshold, your matrix is stable.
All right, Phase 4, Protocol Delta, the lipid finish.
With the matrix stabilized, remove the skillet entirely from the heat source to begin the concluding phase change. You need to blanket the entire surface of the matrix with a payload of 1.5 cups of shredded Mexican blend cheese, specifically a cheddar and Monterey Jack mix. But whatever you do not stir it in. It has to remain on the surface. Once that cheese is deployed, slap the lid back on for exactly 3 minutes. This strict 3-minute covered resting time is required to trap the residual thermal energy radiating from the matrix.
This trapped heat forces the cheese to undergo a phase change, melting it into a single cohesive hydrophobic layer right across the top of your dish.
Finally, we apply the garnish. Fresh cilantro and chopped green onions provide bright, vegetal notes. But honestly, the real game changer here is the cold sour cream. According to the source material, it provides a severe thermal and textural contrast. You are basically introducing a cold, smooth lipid against a hot, heavily spiced, structurally dense matrix. It's a calculated sensory shock, and it's incredible.
Let's move to Phase 5 and see how this builds. The Red Team Report, Counter-Analysis. In the interests of scientific rigor, I found it super fascinating to look at the peer-reviewed critique of our methodology. The devil's advocate position highlights something known as the acid-starch conflict. You see, traditionalists heavily advise against cooking pasta directly in an acidic tomato sauce. Why? Well, because acidity physically inhibits the breakdown of starch molecules. This means the macaroni takes significantly longer to become tender than it would in plain water, and you run the very real risk of it cooking unevenly, leaving you with pasta that's kind of mushy on the outside but hard in the center.
So we have a really clear comparison of methodologies based on this bias check. The one-pot method we executed today is heavily biased toward Americanized convenience. It gives you speed, fast cleanup, high caloric density, and a naturally thickened sauce from those released starches. On the flip side, the traditional two-pot method, where you boil the pasta separately in alkaline salt water before folding it into the meat sauce, guarantees perfect al dente texture. However, that two-pot method completely sacrifices the structural sauce thickening benefit we achieved, and it literally doubles your cleanup time.
So, the crucial point is this: your approach entirely depends on your desired outcome. As you evaluate this explainer for your own kitchen, you have to ask yourself a high-stakes culinary question. Which do you prioritize? Are you going for the efficient, naturally thickened, Americanized one-pot speed, or are you chasing the exact, mathematically precise, culinary textural perfection of the two-pot method? The protocol you choose is entirely up to you.